In this video, we'll be exploring the units of data storage used within a computer system. All data stored in a computer is represented in binary form because it's simpler and more cost-effective to design components that recognize only two states, on or off. Consequently, every aspect of a computer system operates using the binary system, wherein only zeros and ones signify the on and off states. Each of these are referred to as a bit, which is short for a binary digit. We can chain these bits together to form more useful pieces of information. Chaining 4 bits together creates a nibble. Chaining 8 bits together then creates a byte. Bytes are used to represent lots of useful bits of information, such as letters, numbers, or parts of other files on your system. We'll explore these concepts in more detail in other videos. While a single byte is useful for storing a single letter or number, if we want to store more complex pieces of data, then we'll need more space. That's where a kilobyte comes in, which lets you store 1024 bytes of data. As the binary system is a base 2 system, a kilobyte is 2 to the power of 10 bytes, which is 1024 bytes. As most of the time in maths and science, a kilo means 1000, we tend to approximate this value to 1000 bytes. For your GCSE exam, it's perfectly fine to just remember the decimal values here, in this case 1000 bytes, rather than remembering the exact binary values. The higher units are calculated using powers of 1024 bytes. So megabytes are 1024 squared, approximately 1 million bytes. Gigabytes are 1024 cubed, or approximately 1 billion bytes. And a terabyte is approximately 1 trillion bytes. For the purpose of your exams, it's probably easier just to remember the sequence of units. For example, if you know that a kilobyte is 1000 bytes, just adding 3 zeros onto the end lets you know what a megabyte is. You'll also need to know how to convert between these units for your exam. Luckily, this is pretty straightforward, as for the most part you can just simply multiply or divide by 1000. For example, if you want to convert 3250 bytes into kilobytes, then simply divide 3250 by 1000, which gives you 3.25 kilobytes. The only difference here is when converting between bytes and bits. As a byte is 8 bits, you need to divide or multiply by 8 to convert between the two of them. We measure the capacity of storage drives using these units, and you can see some example capacities on the screen now. If we want to calculate how many 300 kilobyte document files we can store on our 1 terabyte SSD, we first need to convert these values to a common unit. In this case, let's go with megabytes. To do this, we divide 300 kilobytes by 1000 to get 0.3 megabytes, and times 1 terabyte by 1 million to get 1 million megabytes. We can then calculate the number of files that the drive can store by dividing the drive size by the file size. So in this case, we divide 1 million megabytes of SSD space by the document size of 0.3 megabytes, which gives us 3,333,333 files that can be stored on the SSD. For your exam, you'll also need to know how to calculate the file size of text, sound, and image files. Text file sizes can be calculated by multiplying the bits per character, which is the number of bits that we use to represent a single character, by the number of characters in the file, including spaces. We'll go into more depth on how computers represent characters in binary in our next video, but for now we'll say that the bits per character for our file is 8. So, if we have a file with 150 characters in it, including spaces, then we can calculate the file size by multiplying 150 by 8, which is 1200 bits. To make this a bit more friendly to read, we can convert this into bytes by dividing by 8, meaning that we have a 150 byte file. To calculate the size of an audio file, you need to multiply the sample rate, which is the number of samples taken per second, by the duration of the audio clip in seconds, and then multiply that by the bit depth, which is the number of bits needed to store each sample. If we have a look at our example on the right here, we can count the number of samples, the number of blue dots in this case, that are taken in a second. In this case, that's 7. We can see along the bottom of the graph that the audio file goes on for 3 seconds, so our duration is 3. Finally, we can see on the y-axis that there are 4 bits that are used to store our data in this file, so our bit depth is 4. If we multiply these 3 values together, we get 84 bits, and then if we divide by 8 to get the number of bytes, we get around 11 bytes of data. Image file sizes are calculated by multiplying the width of the image in pixels by its height in pixels by the color depth, which is the number of bits used to represent a pixel's color. In the example image on the right of the screen, we can find its height and width by counting the number of pixels in both directions, which, in this instance, are both 18. To find the color depth, we look at the number of bits that we're using to represent the colors, which in this case is 2. Therefore, we multiply 18 by 18 by 2, which gives us a 648-bit image. Dividing this by 8 to get the file size in bytes gives us an 81-byte file. So, in this video, we've covered that a computer stores and processes all data in binary, which are ones and zeros or on or off states. A single binary digit is called a bit, which is the basis for all other data units in a computer system, including nibbles, bytes, kilobytes, etc. We've also learned that the storage capacity of a drive represents how much data the drive can store, and have also learned to calculate the sizes of text, audio, and image files stored on the computer. So that's the end of this video. If you'd like to test your knowledge and access other lesson resources, then make sure to head on over to revisio.uk.